Continuing with our monitoring theme, our next speaker is Tom Smith from BNL, whose talk I'm not going to try and pronounce because I think he's intentionally giving me a tongue twister with all the
three M's.
The three M's. This is Minnesota Mines and Materials talk. Okay. So thank you, Tom.
Yep. Can you guys hear me all right? Okay. I just want to say it's been really interesting to see all the scientific talks from the last couple of days. I really love to see what people are doing with Condor, all the good science that they're producing. But I'm not a scientist, so I'm going to approach this from the other direction. I'm an administrator, so I don't use Condor, but rather Condor uses me. So let's just jump right in. Cool. So this was originally going to be a site report, but maybe a site report's not so interesting to some folks, so I just condensed the essence of a site report into a single slide to make room for some more interesting things. So we currently operate 3 pools. We have the Atlas Experiments Tier 1 pool. The S-Phoenix pool is actually new for us this year. We cooked it up in the last couple of months. They were formerly tenants of our shared pool, but they had a lot of dedicated resources that no one else could touch. And we moved them off onto their own pool, and they've just absolutely exploded in the last year. They dwarfed the shared pool by a factor of 3. And then, of course, the aforementioned shared pool is a catch-all for everybody else. In the true spirit of Condor, the smaller experiments can take advantage of idle cycles that the bigger experiments are not currently using. So this covers Star, Bell 2, Phoenix, Dune, Atlas Tier 3, and probably some others that I did not put on there. It was a busy year for us. Some of you may have heard that Enterprise Linux 7 went end of life last year. So we had to migrate everything to something else. That something else that we landed on was Alma Linux 9. I know some other facilities probably went with Rocky, which was a popular choice, but we used Alma, and we're pretty happy with it. We rolled out a new provisioning system, Foreman. I'll talk about that in the next slide. Our Puppet code was updated. Addition of 23, I think that number's right, 23 new racks of compute to the tune of about 100,000 logical cores. It's effectively basically doubled the size of our site in one go. We retired some truly ancient servers. You love to see that. You hate to see really, really old stuff sitting around forever. We have a new ARM architecture queue that we're really excited about. That's for the Atlas Tier 1 pool. It's very small. It has an Ampere Ultra, an Ultra Max, and a pair of NVIDIA Grace CPU systems that just blow everything else out of the water. So those are really exciting. I have a bonus slide for benchmarks. We probably won't get to the bonus slide, so you can check it out on your own. And of course, some monitoring improvements that I'll talk about. So for the management part of things, I have depicted here my holy trinity of systems administration. Some other people might have a different holy trinity, but the idea is the same. So when you start with a blank VM or a bare metal system with a new hard drive that has nothing on it, you have to do something with it. You have to give it an OS. That activity is provisioning. So we use Foreman to handle this. It does the OS management. You netboot the server, you netboot the VM. It'll pick seed, DHCP, TFTP, kickstart, or if you're a Debian guy, pre-seed, partitions the thing. You netboot it, you walk away, you get an OS. That's provisioning. Foreman also serves as our Puppet external node classifier. It's kind of our front end for Puppet. It handles the parameters of the hosts and also the environment switching. Mentioning Puppet, does the orchestration side of the business. Now you have a brand new system with an OS, but it doesn't do anything. It doesn't have your software. It doesn't have your configuration. It doesn't have Condor. You can't use it. So what happens next is it comes alive. Puppet will handle the post-install configuration. It also runs on a schedule every hour or maybe every 2 hours. I forget which one. And this ensures compliance. If you change something that you are managing with it, it'll change it back. So that's great. And also version control with Git. Now, Git is pretty generic, so why is it in my holy trinity? It plays really nice with the other parts of this. Basically, if we create a new Git branch to deploy a feature, maybe a new configuration, this kicks off a webhook. This thing called R10K deploys this branch as a Puppet environment. So now we can assign machines to the Puppet environment. We can test our changes, develop our changes. And eventually, when your changes make it to production, Puppet will deploy that change across the whole place. So this is my holy trinity. So this actually, I think, is an old copy of the presentation because I removed this slide to save some time. But anyway, since it's here, I'll talk about it. This is just one screen, a host list. This, for example, is a list of EPs. I redacted the names. It's not important. You can see the OS that they're using. The host group is important because it determines the end state of the machine. So these are all Atlas worker nodes, Atlas EPs. When these machines are net booted, they're born, they're configured, they become Atlas worker nodes. We start Condor on them, they run jobs. And the last column all the way in the end is the Puppet environment. These are all production, but they could be in a testing branch, they could be in whatever, feature branch. So going to the second M, maintaining the HTC system. The end of EL7 brought on many challenges for us, but also great opportunity. When you're forced to change everything, you can make some good changes. We updated the infrastructure, obviously the OS upgrades. We dropped Red Hat Enterprise Virtualization for OpenShift for our VMs. That's been an interesting change. We're updating the HTCondor configurations. We're always working on this. There's a lot of technical debt that we've been cleaning up. A lot of outdated redundant configs are gone. We like to use defaults when possible. We trust that the Condor developers know more about Condor than us. So if we want to do something different, there has to be a good reason for it. So we like to use the defaults whenever possible. And also we capture everything in configuration management. We had a lot of one-off systems that someone changed something by hand, it was in production, you blow the machine away, now that change is lost. So if it's not in Git, it didn't happen. One-off manual changes are just simply not allowed. And within the last 2 years, we upgraded HTCondor a bit, and that's kind of selling it a little short. We went from 9 LTS to 10 LTS to 23 LTS. We stopped off at a feature branch to grab some critical C groups fixes, and then went back to 24 LTS immediately when that dropped. So going through the upgrades, we had a couple different upgrade strategies, so I'll talk about 2 of them. There's a rolling upgrade, also called mixed major version pool. So the following steps, you can do them in basically no particular order. So you drain your EPs in batches. You can kind of see this graph stepping down. Those are the batches of EPs disappearing. We're upgrading them in batches and adding them back to the pool. So that starts to step up. Same thing with the APs and the CEs. You upgrade them, you add them back to the pool. And the central manager, which I was very worried about, but is actually the easiest part. The central manager can go out to lunch for an hour. It comes back. Nobody even knows it was gone. Some pros of this approach, 100% uptime. You can see the pool existed throughout the entire upgrade process. It's great. We love that. That's mostly transparent to users. I say mostly because if the AP that they're using goes down for an upgrade, then they might notice that. And the pool's, of course, unified for the upgrade. Some cons, you have a mixed version pool during the upgrade. I did a very extensive compatibility testing. I didn't find any problems, so I was pretty happy with that. But I listed it as a con because maybe you'll hit something. I don't know. The configuration of your new and old pool while they're mixed have to play nice together. Obviously, when you're done, you can change your configuration to whatever you like. And it just feels a lot like testing in production, which is not a really nice feeling. Strategy number 2, you create a separate pool, aka new pool, who dis? You start with creating a vertical slice. So you get a brand new central manager, new or more likely stolen EPs from the old pool. Same thing with your APs or CEs. You steal them from the old pool, just a couple of them to make your vertical slice. Then you want to test your vertical slice in a production-like circumstances. Maybe you can find some brave users that want to throw real jobs at this thing. And you just keep repeating this until you're satisfied with it. When you are, you just drain the old stuff, rebuild it, do whatever you have to do, put it on a new thing. So this is a graph of the S-Phoenix pool kind of coming into existence. You can see the initial bump is our vertical slice. It's a pretty big vertical slice, but that was a new purchase, so it was up for grabs. And then eventually, when we were happy with the configuration, we just added everything else to it and called it a day. So some pros to this, your new pool doesn't have to be similar to your old pool at all. It can be completely different. They're not mixing, so you can do whatever you want with it. There's no It's a totally homogeneous version, so you don't have to do any compatibility testing between version interoperability, which is nice. Some cons, your pool is split during the upgrade. You'll see your old capacity will decrease, your new capacity increases. Your users might be like, where's my compute? What happened to my jobs? There's nothing to run on. And the answer is use the new pool. So jumping ahead to monitoring, everyone loves monitoring. Everyone always asks, oh, what are you monitoring? How do you monitor? Everyone loves this. So this is actually new for us. We implemented Condor Ad Stash. It plays well with Elasticsearch, but if you're like us and don't want to pay for Elasticsearch, it also works good with OpenSearch. So this is just, I guess, the last week. I just grabbed that. There's 5 million hits. These hits are all completed jobs. And just an expanded record of a completed job. You can see that the CIA redacted most of this stuff, but it includes all of the attributes from a job ad listing. So this is really handy because you can index this, you could search this. It doesn't roll over like your history files. You know, our history files roll over pretty quickly, I guess. But this will go back as far as you have storage space. Grafana and FifeMon. I won't go too deep into the how, but just we have this. I linked 2 presentations. There's a presentation from HTCondor Week 2017. This is someone at BNL talking about when we first deployed it for us. And also I linked another talk from 2016 about FifeMon in general from, I believe, Fermilab. So this is just a snapshot of some of our panels. I monitor these panels for my 3 pools pretty much all day, every day. I look at this all the time. But you can get some interesting information about your pool as it's running, as opposed to AdStash, which is jobs that have completed. So the CPU usage, for example, you could say, hey, my pool is full, but I have a lot of CPUs to spare. What gives? But looking at these graphs, you can say, oh, I see, it's pretty clear. My memory usage is through the roof. I can't fit any more jobs because there's no more memory. So I look at this and I say, oh, this pool is healthy. It's not doing anything bad. This is some more plots from the same thing. I couldn't fit them all on one screen. I included this time range. I cherry picked it because it includes in the top right a graph of our APs for this pool. And we were really proud of this. We were able to get 50,000 running jobs on single APs. This was important for this pool because we had 130K logical cores and we wanted to be able to fill it with the fewest amount of APs possible. This was important to the production of this one experiment. They wanted to be able to fill the pool as a single user easily. So we can do that. We also have plots for idle jobs, for your APs, other things that might be interesting to Condor nerds, and held jobs, for example. Someone has 12,000 held jobs, maybe that's worth checking out. Prometheus node exporter. This isn't specific to Condor, but it's very important if you want to debug certain Condor things. This is just a snapshot of one of the Atlas worker nodes. You could see this CPU graph is just completely full. It's pegged at 100% for many hours. And when I see this, I'm like, yes, that's good. We're doing throughput computing. You'd love to see this. What you don't love to see is this other one. So we had a node that was having some serious problems. This thing, you know, the out-of-memory killer declared open season on it. It was swapping like crazy. What's happening? So we can look at this and see important things for that. And then also down here, we have overview dashboards. These will aggregate things like your total CPU cores, memory, stuff like that for your pools. And it's good for just getting a bird's eye view. And if you see a problem, you can maybe dig into it more deeply. Honorable mention here is Nagios. It's not pictured because anyone that's seen Nagios would know that it's very ugly and it's not good in a presentation. So it's very important to a monitoring though, because it'll send you alerts when things are going wrong. I had another slide in between here. I guess this is an old version. So based on a conversation I had with Greg and with Todd yesterday, I wanted to put together a wish list for Marone. Is Marone in the audience?
Must be.
Okay, so someone can tell Marone that I want this. We've been doing a lot of version upgrades, and every time we do a version upgrade of our pool, we're draining a lot of EPs, and this is a very expensive process for us. We're wasting millions and millions of CPU hours every time we want to upgrade our Condor version. So what I would love to see, and maybe it's an impossible request, but you guys can tell me, I would love to see a way to upgrade Condor without draining EPs. So maybe you can have your old jobs finish under the old version, new jobs spawn under the new version, however you want to do it. If there's a way to make upgrading less painful and less wasteful, we would love to be able to do it, because then we can follow the LTS, we can keep our pool up to date and not have to worry about wasting a tremendous amount of computing power. So that's kind of my one slide wish list. Acknowledgement, I won't go through the whole thing, but thank you to a lot of people. Very special thanks to TJ. DJ, been meeting with him bi-weekly for an hour for the last couple months. He's been fielding all of my insane Condor questions. He's been very helpful. So thank you, TJ, and thank you the rest of the Condor team. That's it. Thanks.
Do you have any questions? The good-looking man in blue in front.
Why, thank you, good-looking master of ceremonies. I'm wondering, just by show of hands out there, does anybody agree with the statement that they would like to see something to allow the execution points to be upgraded without losing bad put? Of course, everybody would like this, but I mean, it's a problem for your site, Yeah.
I should just point out this question should probably be asked to the system administrators who are in the other room right now.
I'll get them during the break.
Okay, thank you.
But yeah, there's a lot of fixes in LTS that we would love to be able to include, but unless it's a critical, absolutely can't live without it, we often can't justify going for each LTS version, just because every time we do, we waste millions of CPU hours.
So we need to put more bugs in? Is that what you're saying?
Yeah, more bugs.
Okay.
As long as it,
Yeah.
I don't care how many bugs, as long as it works for me.
Hello. Thanks for this presentation. I guess my ears perked up when you were talking about Foreman originally.
Yeah, sure.
Do you use Foreman for the package management stuff as well, or just for the provisioning?
So we use Foreman for the provisioning. We also get an initial package list through Foreman. So that's basically your kickstart or your pre-seed if you're a Debian guy. The Puppet, basically the orchestration that happens after determines the real set of packages we get. So
Okay, so but you don't use I think what's pulp or like the bits that actually you import repositories.
No, yeah, that's more of like you would see that in like a satellite install.
Yeah,
pulp, it's got the Catello, it's got all those accoutrements.
Okay, yeah. So I guess my question was
you can do that. You can bake a lot of things into Foreman. It's very extendable. There's not a lot of things you can't do with it. But we use Puppet for that side of the business.
Well, let me ask the crowd then. If you use the Catello bits in Foreman, please talk to me. Something is not working for me. And I have one more question actually. So I noticed you said both Kickstart and pre-seed. So do you not have just like Red Hat type of things across your farm, or
no? We have a homogeneous farm. It's all Alma Linux, but I've worked at other facilities and we've deployed Debian with it, Ubuntu, CentOS, not Red Hat. We use Satellite for that, but that's Foreman under the hood. A couple
okay.
You can go crazy with this, really. You can install basically any modern Linux OS that you can think of, you can install with Foreman. And you can also run it on anything. So you can run it on a Red Hat or you could run it on Debian if that's your thing. You don't need Red Hat to run this thing.
Awesome. Thank you very much.
Okay, I think I have time for one more quick question from Zoomland.
Hey, Brian.
Not actually from Zoom, it's from me. And not so much a question as a comment.
Yeah.
So at the CHTC, we do a lot of in-place upgrades of APs. So speaking to your new pool who dis strategy of upgrades, one thing that may make it a little bit more transparent to the user is we stand up a brand new AP. Maybe this is new hardware, maybe it's a new major version.
Yep.
And then we do kind of a bunch of rsyncs and change CNAMEs, transparently move the AP under the feet of the user so they don't notice, so that we can like test the new AP without actually affecting the users and make it a bit more seamless. So we should
Yeah.
talk.
That's really interesting. We've done something a little bit similar. We created, like you said, a new set of EPs, and I transferred some things that were needed, but there was a clear change for the users because when we did this, we made new APs, new DNS names, new everything. I think back to Greg's talk, I think 2 years ago, about what is a name, and a name has a lot of power, and we had a lot of really old names that didn't mean anything to someone that we just hired. Like I started 3 years ago. I'm like, what are these names? These make no sense. So we burned the whole thing down. We've got new names for everything. It makes sense. You love that. The name has a lot of power. So it really took advantage of this opportunity.
Thanks.
Okay, thank you, Tom.